we've been asked to compound this?
Interest rate is minus, right? Or is that adding? I don't remember.
It should almost always be adding. It's going to be incredibly, incredibly rare that it has a minus. Mostly, I added one of those in for us yesterday so that we saw that it could have a minus, but it is, I think, one of the only times we'll ever see it with a minus. So most savings accounts will earn you interest. So if we were building the equation just off the story, not doing any of our compounding, we're going to put n in for compounding. How are we going to build this equation? What are we going to start with? Our 1,000, that's going to be our starting amount, right? So if we're building this equation, we're going to have our 1,000. We're going to have our 1 plus this is going to be where we put our compounding factor, and this is where we're going to put our compounding factor. It goes in two places. That one on the top looked weird, so I'm going to rewrite it. There we go. What goes here? 0.04. We take our percent rate and we write it as a decimal. 0.04. Whoop. What else do we need to put up here? The 10. And that goes up in the exponent. You're exactly right. It's going to have our n times 10 up here. NT. So for each one of these, we're going to have a different n. And then it's just going to be kind of plug and chuggy. So for annually, what's our n?
1.
N is 1. For quarterly, what's our n? 4. Good. 4 quarters in a year. How about for monthly? 12. Daily. 365. Hourly. That one?
I don't know that one.
Well, we know that there's 365 days. And we know that each day has 24 hours. 8,760. So now that I know how many hours, we could find out how many minutes, because we could times that by 60 minutes in an hour, or we could know our proper Broadway history and know it's 525,600 minutes. Good song. I'd say, but we could also math it and write with better handwriting, because singing and writing at the same time is bad. So these gives us our n's, and we can do plug and chug. And when I did months, I apparently wrote an m, so I'm fixing that too. There we go. So on all of these, we're going to put these pieces in. I want us to see what happens to the balance as we change these pieces going through. So work through, type in some of these in so we can start to see what's going to happen to our balance. I'm going to freeze my screen because I'm going to put them all up here. Thank you. Huh?
What are we doing?
Oh, we're doing the bell work right here. It's just a bunch of different compounding. We're using it to see a thing. I'm just writing it down at the same time while people are working through it. Because there's 6 of them. It's a lot. But I was writing it down so then I don't have to calculate it in the calculator each time. Oh, snap. I was writing them down on a Post-it note before I start talking again. Because y'all still working, and I like it. Alright. So what have we started to notice as we go through this when we're filling in these values? Is it just getting more and more and more and more interest and more, and I want them to compound as much as we can? And if I go minutely, I could go secondly, I could go quarter secondly, I could go millisecondly, and keep going and going and going? Because when we have annually, how much did we get when they compounded our interest once in the year?
1480.24.
Yep. So that's kind of like the lowest amount we can get interest-wise. Everything's going to go up from here. What do we get for quarterly? If our n was 4.
1488.86.
Mm-hmm. And for our monthly?
1490.83.
Yep. How about for our daily?
1491.79.
So even if I just look through those 4, is our amount that it's changing the same? If it's changing between these guys? Because here we got 8 additional free dollars. Here we got 2 additional free dollars. Between these two, I got almost $1. So the amount that this is changing between each one of these is getting very, very small. Let's see what happens with our hourly and our minutely. And they're both going to be what? For both of them, the farther out decimals are off. Because the first one was 82 cents and 3329. And the minutely was 82 cents 078 or 748. So like the further decimals were a little bit different, but as far as practically, they're about the same. So what we notice with this is when we are doing these compounding interests, there is only so far it can go. There's only so close together that it'll go and still have it affect some sort of change. So what we're going to be looking at today is a part of the formula, the formula that deals with when it starts to do that, as it gets closer to hourly, minutely, secondly, quarter secondly, millisecondly, and we start heading towards something that is called continuously compounding. That's what we're going to be working our way towards today, and that's why we had so many of these and we sat upon them for a little while here, is it's leading us into what we're talking about today. Okay? It's going to feel kind of like a shift here for a little bit, but I promise we'll get back to the bank account stuff. Questions on our bell work stuff. So this is what we did yesterday. Okay. Because if we notice, this is approaching, like there's a maximum amount that we're going to get interest-wise. That is about as close as we can get. There's not going to be much more that we get, even if I was to go up to our secondly, millisecondly, things like that. So somebody took all those calculations. They did this a bunch of times. They figured out where it was going to be and what that number was going to be. And that guy's name was Euler, the guy who figured this out.
Hold on, wait, what?
His name was Euler. It sounds like ruler without an R. But his name is spelled E-U-L-E-R. The only reason we really know that is because he named the number after himself.
Of course he did.
It's called Euler's number. We just call it E. It's kind of like pi, but it's used way less frequently. It's mostly used in this particular banking equation. There's a couple other places that it's used, but it's mostly used in this kind of stuff. This is what it is. It's another non-repeating irrational number, very similar to pi. It's just called e. It is, in fact, a button on the calculator.
Is it the next one?
Yep, because we are going to be using it always with exponents. So I'm going to go ahead and pull up the calculator, and I can show you where it is. Oops. Bless you. So E is if we hit the green button up here, and then we hit the little one that has a lowercase l and an n. It pops up an E. It's always going to put us up into an exponent because E always works with exponents. But if we want to see the value of E, we can just do e to the first. That spits it out. We are very rarely going to just work with E all by itself unless we are simplifying, in which case we don't need the calculators, or it's going to have an exponent, in which case we're going to type in whatever exponent we have. So it's a button on the calculator. His name was Euler, so he called it E. But that's why we've never had something like E of X, or we've never used E as a variable because it has a meaning. I don't know that we've ever actively noticed that, but that's been something that we have never done because E is a thing. When we start working with E, it feels really weird. It's kind of like when we start working with pi. Then we get used to it and we're all right. So the first thing we're going to do with E is we're going to practice a little bit of simplifying using E. Meaning, I'm going to give you stuff like this.
Yeah.
We are not looking to get a decimal answer. We are looking to simplify. On these ones, when we are simplifying with E, there should still be an E in our answer. So when we have something like e to the 7th times e to the minus 2, treat it just like we would if it was an x. What would we do if this was x to the 7th times x to the minus 2?
We would add the exponent.
Yeah, we'd take our x to the 7 plus negative 2. We will do the same thing with our e's. E to the 7 plus negative 2. What is 7 plus negative 2? E to the 5th. That's our answer. We see e's, we start to panic. Treat them like they're x's. Let's look at this right one over here. We got 36 e to the 5th over 9 e squared. What can we do over here? Remember, treat our e's like they're x's. What would we do if this was 36x to the 5th over 9x squared?
We would see if 36 can be divided by 9.
That is an excellent place to start. Can 36 be divided by 9?
Yes.
Yes. What do we get when we divide our 36 by 9? 4. Then let's look at our e to the 5th over e squared. Think about if it was x to the 5th over x squared. Yes. We're going to have our e to that, and I'm going to write it out one more step first, because if we have our multiplication is when we add our exponents, when we divide, we're going to subtract. So we're going to have our 5 minus 2. So our answer here is going to be 4e to the 3rd. So simplifying using e is just like if we had x's there. Oh, that is never mind. I'm not going to color in that box. I will rebox it so I can color it because I don't like it not being colored in. There we go. Better. Okay, so simplifying with e's, even though we know e's a number, and yes, I could type those in the calculator, but never ever will they be nice or pretty. They will always be decimals that go all the way to the edge of the screen.
Ew.
Because that's how E is. E never comes out nice. Because it's one of those real world limitations. And the real world very rarely wound up in nice whole numbers. So we're going to practice this a little bit more, because sometimes we're going to see these and they look a little gross. These ones aren't awful, but we've had worse ones. So again, remembering those exponent laws, because I would bet dollars to donuts that we'll see something that involves our exponent simplification tomorrow. For those of us that are juniors. I bet you will see something with exponents that you will need to simplify tomorrow. I would be absolutely shocked if there was nothing with exponents. Okay? So, when we have a set like this, what am I doing? Whether it's e's, x's, or 2's, doesn't matter what can I do with these exponents? Add them. 4 plus 3 plus, what do we put for this guy? What's his exponent? 1. It's not written there, but every number has an invisible 1 as an exponent. We just don't typically write it, because if I put 60 to the first and 12 to the first and e to the second and e to the sixth, it starts to look real crowded. We just don't typically write it. Kind of like we don't always write that this is 1e. It's that invisible math, we just don't write it because we're lazy. And that's okay. Most of the time, it's okay to have a little bit of moment of laziness. So this becomes e to the what? What's our final answer in this one? 8. There's our answer for that guy. Boop. Let's look at the one on the right. 60 e to the 6 over 12 e squared. What we gonna have over here?
Divide 60 by 12.
Divide 60 by 12 and we get
5.
5. What can I do with my e's? Subtract. So we're going to take our e to the numerator minus denominator. 6 minus 2. So our final answer is going to be 5 e to the what? 4. Okay? Working with e's is just like working with x's. They're just weird. So the simplifying with e's, we treat them just like it was simplifying with x's. We do not need to get decimal answers. Leave them be. The only time we're going to use these to get decimal answers is when we start working with our banking stuff, which is going to give us, I believe, our second to last new formula. We're going to have one more formula to do with our banking stuff. Remember, we're giving you all the formulas on the test. We just know how to use them. So this is going to be one of the few equations that looks very, very different from all the others, because all the other ones kind of build and expanded outwards as we got more and more and more information. Well, as we get our intervals to be closer and closer and closer together, go ahead. Oh, the adhesive is just very strong, so I was helping with that. So as these intervals got closer and closer together, like we saw in the bell work, we're going to approach something called continuously compounding.
Oh, God.
And this is a new equation. Most people will go, pert. So we're going to use our pert equation for this. It's P, that's our principal, the same one that we had before. So when we wrote our compound interest formula, that was our P with our 1 plus R over N to the NT. That's the one we used in the bell work. So a lot of the pieces are the same. We still are using our P for our principal. That's our starting amount. We still have our rate as a decimal. Only thing is, this time our rate is in the exponent, up there with the t. And the thing that they are on as their exponent is they're over that e. So e is that button on the calculator. I didn't use blue, so let's do blue. This guy, that's our e, and that's the button. We use the button for that. We do not need to know the number. It does not help for you to know the number. Please do not work to try and know the number. It's not even a great party trick, because no one will know if you're right. The more decimals of pi you know, people are impressed. The more decimals of Euler's number you know, people are a little concerned. I have to look up Euler's number every single time. I do not have it memorized. And there was a time when I could sing the pi song that gets up to like 100 decimals.
Yeah, based on science for seconds.
Uh-huh.
Classic.
Classic. 3.1414. Okay, so this is the equation we're going to use. It's all the same pieces. We're just putting stuff in different spots. So these kinds of problems, we will give you stories kind of like this. So if we have $1,000 compounded continuously with a 4% interest rate in 10 years. That's awfully familiar information, huh? So this is looking at that same kind of situation that we had, say, in the bell work. What happens when we do it with pert? So our pieces are still the same. This is the exact same as the bell work problem, where we had our principal of $1,000. So writing our equation, we're going to have our 1,000. Then we're going to have our E, which is a button on our calculator, to our rate. That was our 0.04 times our time. That was our 10. And what we're going to do is we're going to type this in the calculator. And I'm going to show you how to do it because it's new. So to type this in our calculator, we're going to do our 1,000 to get to our E. I'm going to show you the physical buttons we push. We push the green button on the top left. Then we push 2 down from it. LN, because it's our little E. Anything in the green, we have to hit that second button to get to. That's where we're finding E. E exists on all calculators that are more than like the little ones you get at the dollar store that are like this big, the size of like a card. Anything bigger than this has an E on it somewhere. If you have your own calculator and you can't find your E, let me know. I can find it. But on that E, that's where we're going to put into our decimal or into our exponent our 0.04 times 10. We don't have to simplify it. We can do that here. You can also multiply that one. That one's not particularly difficult. But when we multiply that, we get, honestly, right about where we were on the bell work. It's the same value. It's just instead of doing our hourly, minutely, keep going and doing secondly, quarter secondly, millisecondly, this equation lets us do it without having to figure out how many seconds there are in a dang year, because that's a lot. Or having to type in 525,600 minutes and then have the bank figure out how to do minutes and put them into your bank account and have it not take up an entire computer to do each person. So we can put them in like that, and this is how we get our compounded continuously values. So our value in our account was our 1,491 and 82. Most of the time when we give you these kinds of problems, it'll be worked in with other bank account problems. So it'll be in with things like this. I'll give you a bank account. We'll say compound this annually, compound it monthly, compound it continuously. We might give you another one in there too. A lot of times we'll give you 4 just because 3 looks weird. 4 is a nice tidy grid. Usually that's why it's 4, because we want more than 2, but 3 looks weird.
So are we using like both of our equations?
We will need to use both equations on this. So we will, for the left two, our annually and monthly, we'll use the P1 plus or minus R over N to the NT. And for our continuously, that's when you use our pert, PE to the RT. So when we have continuous, that's when we use pert. So let's take a look at the situation and find what pieces we have here. What pieces do we know?
4,000 is our starting.
4,000 is our starting amount. That is our P for both of these guys. What else do we know?
0.054.
Our rate, yep. So we're going to put in for R. We got to scooch that over twice, and you're exactly right. We're going to have our 0.05. Oh, now it froze. There we go. 5, 4. If we can't remember how to do percents to decimals, because honestly, that's where I get a lot of people with points off. Percent per number of cents in a dollar, 100 per 100. 5.4 divided by 100. That's what percent means. It literally means divide by 100. So that tells us our R for this guy and for this guy. One more piece from this top paragraph. One last piece in this part. The 8. We've got our time. We are looking at for when this is at 8 years. So I could fill in my PERT equation entirely, but I'm going to start with annually because it feels weird to start at the end. So when we start to fill these in, we're going to have our 1,000 with 4,000. Yes, that's 100% what I meant. Totally. Definitely did not zoom in too far on that one. Are we using plus or minus? Plus. It says pays. That is a great way to notice that. Honestly, it's only going to be minus if we specifically say that it loses when we're looking at these plus or minus ones. So then we have our rate, which was our 0.054. What's our N on this one? 1. Good. Annually is an event that happens once a year. An annual gala, your birthday is an annual event. Happens once a year. So we'll have our exponent of our 8 times 1. So type this into our calculator, and you can do it without having to do too much simplification. Thank you, my dear. You can type it in the fraction-y form, and I'll show you that one. I just had to get it marked down. So on our calculator, we can do this by putting in our 4,000 times our 1 plus the fraction, second button, third column down. That has our 0.054 over 1. Close it, and we're raising it to the exponent of 8 times 1. We can type it in just like this. So we have a balance of $6,092.35. $92. Forgot the 0. So what's going to change between this equation we did for annually and what we do for monthly? The only thing that's going to change is the n. Everything else is going to stay the same. We're going to take our 4,000 and our 1 plus our 0.054. What's our n going to be this time? 12. Everything else stays the same. We're just going to switch out any place that we had an n of 1. We're going to put it as an n of 12. So if we do that on the calculator, shortcut version of that, I'm going to go up, up, enter. And then I can go back to my denominator and I can put in a 12. I can go up to my exponent. We're going to have our 8 times 12. Then I don't have to retype everything in. If I have just a very small change to make to the line I've already put in, go up, up, enter, and that'll copy paste it back into your line. So if I want to repeat what I just did, go up, up, enter, and then you can go back and change things. So it's a little bit different here. We've got our 6155.37. 6155.37. So those are the same kind of way we did it for the bell work. Our new one here is our continuously. It's using those same pieces. We've got our principal. That's our $4,000. Then we use our E button from the calculator. Our rate goes up in the exponent, our 0.054 times 8. And we're going to type that in the calculator, and I'm going to do it with you. So we're going to put in our 4,000. To get to our E, that's when we hit the green button on the top left, and then 2 buttons below it that has a little LN. Which we'll find out what LN means in the next chapter. Oh snap, what? So LN, and then our E button up here. And then our exponent, we're going to have our 0.054 times 8, our unit of time.
Couldn't you also do it in parentheses?
You could, absolutely. Talking like that-ish.
Yeah.
Yep, totally fine. And just like when we did it in the bell work, when we took our annually versus our monthly versus our daily, the closer and closer our compoundings get, the slightly more money we get. So here we have 6,161.34. So we get 6,161.34. In real life, most bank accounts give us a monthly compounding for like a savings account. Continuously compounded would be usually how they do something like a fee. Because they want to take more money from you, but they'd like to give you as little as possible. So we will look more at continuously compounding. We will play with some more kinds of equations and some more ways we can see continuously compounding on Friday. But this is one of those things that is, once we get the hang of it, it's not awful. Like we can do it. But it's just getting used to that equation and using that E button on the calculator. Okay? So that technically gives you enough to actually finish out homework 2. We are going to keep working with compounding on Friday, simply because we'll have a day off in between, and then I want to make sure we get a chance to practice doing other kinds of continuously compounded problems, because continuously compounding doesn't just happen in banking. It's just one of those things that we see most frequently in banking. Okay, so few reminders. Homework 7-2 is going to be due on Monday. You can absolutely do everything on it right now, but we're going to keep looking at continuously compounded on Friday, so that's also totally fine. SATs tomorrow. So if you are not taking SAT, you have time to work on your homework, catch up on things, make sure you log into Canvas to get your attendance marked. Work through stuff. This is a great time to catch up on homework. If you have something missing, it's a great time to work on that. Catch up on stuff. There's some old Canvas assignments that a lot of us have not done. They're still open. Check stuff. What's up?
The first ACT practice, can you open that and I can do it?
It should still be open. If it's not letting you in, go through the module to it, because the calendar gets super grumpy about things that are late. It should still be open. If it's not, that is a setting I can change very quickly. Let me look at it. But it should still be available. It's just that Canvas gets super grumpy about letting us into something past due from the calendar, because it wants us to all be perfect and be on time for everything.
says it's still live.
Okay. Well, for some reason Canvas is also not letting me log in. Give me a second. I am spelling my own name correctly. That is my password. Let me in. It keeps putting in the spell check wiggle line under my name. I'm like, I'm spelling my name right. It's my name. Thank you. There we go.
They do that with my name too.
All the time.
My last name.
To be fair, it has happened with my name every single time because my maiden name was not any better. All right, let me get that setting adjusted, and then you guys can get in and do that. That was for the first SAT. So that was the first SAT practice one, the February 18th. Yeah, looks like that one is closed. Boop, boop, boop. Edit. Options. That's not the one. That's all. There you go. If you refresh the page, now it should be available. I'll do the same for all the other Canvas assignments we had, so tomorrow would be a great time to catch up on any of those that are not completed. I'll have them set so that they're open. You might need to go through the module to get to it, but it should be open. What's up, Arthur? I'm just adjusting all the other ones, just to make sure.
Is there gonna be an assignment for tomorrow?
There will not be an additional assignment. Use the time to work and catch up. Mostly that's because about half of my Algebra 2 classes are juniors. And while, yes, we are supposed to assign you e-learning, you're going to work on your homework because I'm going to not be a jerk to my juniors. There we go. All of those, no, I don't want to do that. All of those online assignments should be reopened and available for you. So anything that was on Canvas should be ready to rock and roll. So catch up on those. Now's a great time to do so. Catch up on homework. If you need another copy of any of the homeworks for Chapter 7, they're up in the pocket on the wall. Catch up on stuff. We are at about the halfway point for the year. The quarter ends next week. So let's make sure we're happy with where our grade is.